Okay. All right. So this last problem that we did, I had us graphing this equation, x plus 2y is equal to 10, and creating a table of values and creating a graph using those table of values, creating 5 points and then plotting them. That's all fine and dandy. But I would have to say this is a whole lot of work. The last video was 7 minutes long, and yeah, I was kind of long-winded with it, but at the same time, it was 7 minutes long just to create one problem, and I'm proficient in this concept. So because of that, I want to sort of show you a nice little shortcut, which is kind of cool. So instead of creating a table of values, we are going to check out this neat system with essentially creating a graph using intercepts. So if we think about a graph in general, and we think about an x-intercept or a y-intercept. So I'm going to move my graph over a little bit. But if we think about an x-intercept or a y-intercept, we need to think about what that means in terms of our points. If I'm going to plot a point on the x-axis and find an x-intercept, any point that I plot on the x-axis will look like this. It'll be a number, comma, 0. That means it's not going vertically or horizontally on the y-axis at all. Instead, it's just staying on the x-axis, and the number that is up in front, where the x value goes, is going to dictate where along the x-axis you are. Same thing for the y-axis. If I'm going to plot something on the y-axis, I would need the x value to be 0 because I don't want it to be shifting left or right. I just want to pay attention to how it goes up and down. So we're going to have 0, comma, a number for the y-axis. So because of that, we can use this really cool trick for our math. So I'm going to write this equation much larger. X plus 2y is equal to 10, just so we can see it a little bit better and you can sort of see what I'm going to do. So if I wanted to find the y-intercept, that means my x value is 0. That means I don't need to pay attention to what this x is because no matter what, it's not going to play a role in my equation. So what I can do is I can just cover up this part of my equation, and then I have 2y equals 10. So what does y have to equal if that's the case? We divide by 2 on both sides. 10 divided by 2 is 5. So our y-intercept is 5, or 0, comma 5. We can do the same thing for our x-intercept. So essentially, I'm now going to plot this. I can say 1, 2, 3, 4, 5. This is my point. Now I can do the same thing for my x-intercept, but instead with x-intercepts, our y is 0. So that means I can hide this part of the equation, and I get x is equal to 10. Huh. Isn't that sweet? I just found the x-intercept and didn't have to do hardly any math for it. So then I can say my x-intercept is equal to 10, or 10, comma 0. So if I did this right, I should end up with a graph that looks very similar or exactly the same as the last graph that I just did. The only difference is because I shifted it over, we're going to see more of the graph to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to now plot this x-intercept here, my y-intercepts here, and now I'm going to connect the dots. It's going to be movie magic because you're just looking at my back and it's just going to appear. And look at that. Now I have a line. And it's not drawn beautifully, but at the same time I have a line. Isn't that cool? And it just went through these y-intercept and x-intercept points. So I didn't have to create a whole table of values. I could just use this sort of Hollywood magic to find these other 2 points. And this will work really nicely for pretty much any type of standard form equation, but it'll work really nicely if the coefficients up in front play really nicely with this constant in back. For example, if I had ones that were a little less nice, if I had a problem that was a little less nice, say 5x minus 3y is equal to 10, we can see that this one is going to play really nicely. 5x is equal to 10, so x is equal to 2, which gets me a really nice x-intercept, but my y-intercept is going to be a little more messy. Negative 3y is equal to 10. That means my y-intercept is negative 10/3, which is going to be hard to plot. And in this case, I would say you would want to do a table of values. It'll be easier to plot and you'll be more accurate with graphing it with the table of values. But if instead you used, with the last problem, using intercepts could be really nice. So that is the last official video that I say you must watch in terms of this concept. However, you're welcome to watch the bonus video as well, where I go through a word problem that's similar to the problem that you're doing for the must-do practice problems. So check that out if you need it. And otherwise, start working on the must-do practice problems. Bye.